we're ready to start putting all the pieces together. So we're going to take a look at having multiple, both vertical and horizontal transformations. So the first question I have on the worksheet under this section, our parent function is the absolute value of x. And I specifically say in the directions, include the points whose x values are 0 and 1. So that's going to be the vertex at 0, 0, and then this point 1, 1. And because the left-hand side is a mirror image of the right-hand side, if I've got this point here so that I've got the right steepness for this branch, I'll have the right steepness for the left branch as well. All right, the transformation that we're asked to sketch is g of x, which is 3 minus 2 times the absolute value of 3 times the quantity x minus 1. Oh my goodness. Let's keep track of what we would do in evaluating the function and then the corresponding transformations that that's going to do to the graph. So if I were plugging in a number for x, I can see that the first thing I would do is subtract 1. Once I've got x minus 1, I would multiply that by 3, and then I would take the absolute value. Now that's my parent function. So this stuff that I was doing before the parent function, that's going to affect the graph horizontally. Once I've evaluated the absolute value, I can see I'm multiplying that by a negative 2, and then I'm going to add 3 to that. Now, some of you might find it easier to work with if you rewrite this as negative 2, absolute value of 3 times x minus 1, plus 3. That makes it a little bit clearer that we're adding 3. Sometimes people see that minus sign and they're thinking subtraction. Well, we are subtracting, but we're not subtracting 3. We're subtracting this from 3, which is equivalent to calculating this and then adding 3 to it. So sometimes when I have a number minus what I'm doing to my parent function, I find it simpler to just bump that number to the end and write it as a plus that number. Totally up to you. Okay. So this stuff that I'm doing after the parent function is going to affect the graph vertically. So for the horizontal transformations, subtracting 1 is going to shift things 1 unit to the right. Multiplying by 3 is going to shrink by a factor of 1/3. For the vertical transformations, those are a little bit simpler because they do exactly what it looks like they should be doing. Multiplying by negative 2 is going to be a vertical flip and a stretch by a factor of 2. And adding 3 is going to move things 3 units up. And remember, the rule for the order in which we're doing these things is that we're always moving away from the parent function, which has the effect of saying that for the vertical transformations, we're going to do those in the same order in which we would evaluate things. But for the horizontal transformations, we're doing those in the opposite order from that in which we evaluate the function when we plug in a number for x. Okay, it does not matter whether I do the horizontal or the vertical transformations first. It does matter what order I do the horizontal ones in and what order I do the vertical ones in, but it does not matter which I do first. I'm just going to do the horizontal ones first because I've got those written down on the board first. So I'm clearing myself a little bit of space. I'm going to draw things a little bit smaller so I can fit this all in. So we started with our point 0, 0 and 1, 1. So the first horizontal transformation I'm doing is shrinking things by a factor of 1/3. So I'm going to take my x values and I'm doing the opposite of multiplying them by 3. I'm dividing them by 3. So if I do my horizontal shrink, the x value of 0, if I divide that by 3, it's still just going to be 0. So that point doesn't move. But for this point, if I take the x value of 1 and divide it by 3, it's now going to be at 1/3. So that point becomes 1/3, 1. And so I can see I've shrunk things horizontally. Okay, then I want to shift things to the right by 1 unit. So the vertex was at 0, 1. That's going to shift over to 1, 0. And 1/3 one is going to shift over to 1 1/3, or 4/3 one. And you can see if I follow this up, we will eventually cross that y-axis. It's not serving as an asymptote. If it were, I'd have to be curving to avoid it. Okay. All right, excellent. So there are my horizontal transformations. Now let's do the vertical transformations, going in this order. So I'm going to flip and stretch by a factor of 2. I accomplish that by multiplying all of my y values by a -2. So if I do my vertical flip and stretch, the y values simply get multiplied by -2. 1, 0, it's going to stay at 1, 0 because the y value was 0, and multiplying that by -2 doesn't change it. However, the y value at this point was 1. That's now going to become -2. So I'm going to have a point 4/3 -2. Oops. So it's getting even skinnier, okay? Because when I stretch it vertically, I make it taller and skinnier as well, okay? All right, and then we wanted to move things up 3. Let me just clear some space here. So I'll just come here, moving things up 3. So my x values stay the same, but I'm going to add 3 to my y values. So the vertex, instead of being at 1, 0, now that's going to be at 1, 3. And this point was at 4/3 -2. Well, if I add 3 to that, that's going to bring it up to 4/3 +1. So we've got this skinny upside down V with a vertex at 1, 3. Okay, so we worked through that one together. Problem 2 gives you a parent function of f of x equals x cubed. And in the directions, I specifically ask you to include the points whose x values are -1, 0, and 1. And then in part B, you're sketching g of x. And do this on a separate set of axes. You're sketching g of x, which is 4 plus 2 times the quantity -2 times x plus 1 cubed. Okay, and in showing your work, I need to see all of the individual transformations that you're doing. One way to do that is to individually do them one at a time. If you want to just go to the final graph, draw the parent and go to the final graph, that's okay, if you have explicitly written out what the transformations are and the order in which you're doing them. But I need that at a minimum to show me the work, and my preference is just to do them one at a time. It's up to you, though. All right, should have said, so go ahead, that's going to end this video, but the next video will start with going over this problem. So before you tune into the next video, try working this out on your own.